We are looking at a problem from the independent practice from 1.1c. It's number 3. So this is the idea. We're given this function, right, and it is in graphing form. So graphing form we want to recognize is this guy here, f of x equals a times x minus h plus k, where a, h, and k are all placeholders, right? So there's a number here, a number here, a number there, a, h, and k. And they give us some important information. So the first thing we want to do is be able to accurately pull out the a and the h and the k values from this function. So the a value is a little bit tricky on this one because all you really see there is a negative, but you got to recognize that negative is a negative, and then with a 1 there is a multiplier. That is -1. That is my a value. So my a value, I'm going to go ahead and down and record as a -1. Okay, my h value is the value that comes after the parenthesis, or after, sorry, the subtraction. It's inside the absolute value. So whatever value I see there after the subtraction, in this case it's a 10. And it is a positive 10. Even the negative is there. The negative is part of the structure. And then the last one, my k value, is going to come from this guy here out at the end, right? It's the one that's being added or subtracted. And this time the sign is going to match because it's supposed to be a plus k, so the sign would go with it. This is going to be a -1. So that's my first step. My first step is to identify my a, h, and k. And then I'm going to sort of interpret what those numbers mean, kind of put them all together. The first thing is my vertex. Well, my vertex is always created by my hk values. It's the horizontal and the vertical shift from my parent function, right? And the parent function always starts here with the vertex at the origin. So my vertex here is going to be 10, -1. Let's see. Then I was asked to find, I think, the domain and the range, and then we'll talk about stretch, shrink, and reflection. So let's see. My domain here is going to be the same domain for all of my absolute value functions. It's just x is all real numbers. And that's because this, if I graphed it, I wasn't asked to graph, but if I did, let's see, that would be 10, -1. So that would mean on my x-axis, I'm moving out 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then my y value, 1, 2, 3, so there's -3. My vertex is all the way over here at 10, -1. And then I got a V shape that's going to be going down because my a value is negative. It's kind of going like this. Well, it's moving forever to the left and the right. So as it moves to the left and the right, it will hit every possible value on x will exist as a coordinate on here. So x is all real numbers. My range, however, is a little bit trickier because my range doesn't go forever up and down on the y-axis. It has a top value, and then it is everything below that. So my range is going to be all real numbers. And then it's going to be y is less than or equal whatever this k value is, because that's the shift that I've done on my vertical axis. So that's -1. Okay, and that is a general structure that works with all of these. Your vertex is always going to be hk, and your domain is always going to be all real numbers, and your range is going to be everything. This says above k, but because we had that reflection, because our a value is -1, it's going down. I had to flip that sign and make it less than or equal to -1. Okay, so now we need to talk about the stretch and the shrink, and that comes from A, right? It's right here on our independent practice 2 as well. The A will give you the stretch, the shrink, or the reflection. It's a stretch or a shrink based on the number and whether or not it's essentially bigger than 1 or a fraction. So I put bars around it because we don't really care about the sign on the A value for stretch or shrink. We care about the sign for the reflection. So my A value is -1. And the absolute value of -1 is 1. So really I'm looking at this to decide a stretch or a shrink. And 1 is neither bigger than 1, nor is it between 0 and 1. It's not a fraction between 0 and 1. So that tells me that there is no stretch and there is no shrink. This is actually growing at the same rate as the parent function. The parent function has a slope of 1 on the right side. And this guy here, we said was growing down 1, right 1, down 1, right 1. So it actually has the same growth rate. It's just upside down. Okay. Vertical shift and horizontal shift, that has to do with the h and the k values. We kind of already talked about that to get to the vertex. So we are going to have a horizontal shift. horizontal shift, and that is going to be 10 units to the right, 10 right. We are also going to have a vertical shift because going from the vertex originally at the origin with the parent function, right? Originally at the origin with the parent function, it's now had to shift down as well. So we're going to have a vertical shift, 1 down. And we can get that right from the h and the k values, right? H is 10, that's positive 10. That would mean 10 units right. On the horizontal axis, the x-axis, we're going 10 units in the right direction, the positive direction. Our k value is -1. Negative is down, right? On the y-axis, we're going down 1. And then the last thing we need to talk about on this is the reflection. We've kind of already mentioned it because A is negative. This thing is going down. Yes, there is a reflection. Yes to reflection. And that is because A is -1. The fact that the A is negative, that's what gives it that reflection. It makes it grow upside down. We're going down 1, right 1, down 1, right 1. Okay, I hope that is helpful. Message me anytime with questions.